Today on the Rankled Engineer Podcast, we're going to discuss ASCE 10 wind load representations. And yes, we know it's been a decade, we're going to talk about it anyways. We'll discuss the removal of a stubborn pilot bearing from a Chevy 1500. Our overlord of pronunciation will share the word that annoys him the most when it's pronounced incorrectly. And we're going to talk about Tim's DeLorean. Hi, I'm Gates Brown. Welcome to the Rankled Engineer. I'm here with Tim, and we're going to have some fun. We're both structural engineers, so bear with us. And I actually I think Tim agrees with me on this, the most important attribute of a structural engineer, and that is their arrogance. You'd agree, right? I mean,
I guess so, yeah.
It seems to be a fairly common trait amongst structural engineers. Do you have any thoughts, Tim, on why that is? Why is that such a strong trait in our community?
I don't know. I feel like it just takes balls sometimes to do some of these things.
You get told that you're wrong a lot.
Yeah, that's true.
Everybody owns a house, so therefore they're a structural engineer.
Yeah, everybody knows better. That's true.
So contractors tell you that you're wrong. The building officials like to tell you that you're wrong. Owners complain about cost, and architects, as much as we love them, they complain when we stick columns in their windows and those kinds of things. And I know that you have a fun response from contractors that we often hear.
Oh, you mean I've been doing this for 20 years, that one?
Yes, yeah. And what's your response to that?
Yeah, well, you should know better by now.
Yeah, that's right. Right, because you've been doing it wrong for at least 10 of those years.
That's right.
So speaking of 10 years, today's building code topic that I wanted to kind of discuss, something that really bothers me, it rankles me, if you will, and it's been 10 years, is ASCE7 wind loads. So this is the point in the podcast where if you don't care about the building code, we talk about some fun stuff at the end. Go ahead and fast forward. But ASCE 10 wind loads have been around for a decade. At least the method has been, and it was adopted by the building code in 2012.
Yeah, came from the Southern Standard Building Code procedure that was used for years before that.
Correct. So we modified the wind speeds and then some corresponding factors. So we had roughly the same system. It just was a little bit of a different method to get there. And that produced an anomaly that I've seen with lots of engineers where they just failed to adapt to the new way of doing things completely. They follow the code at the start. They pick the right wind speed, but then they kind of modify the method that we're supposed to follow. And even today,
that's overly simplified in a lot of cases.
Right, and I still see it today. And I've been at a few firms where I've fought the battle to change the way we present our information about wind loading so that it conforms with the model of the code. And there was a change, and we just got to deal with it. And so I want to talk about that a little bit today, why there's that pitfall, why maybe there's some hesitation to switch to alternate wind levels, even though that's really not the correct terminology. I think we'll talk about that and discover what the real terminology should be. So anybody who's familiar with the building code knows that in pre-2010, so from 2000 to 2010, the wind load speed was normalized to an ASD level of wind pressure. And the 2010 switch was to change the wind speed to be normalized to the LRFD levels of wind.
Similar to how seismic is in the same code.
Right, so it adjusts seismic, makes them at parity with one another. Even though we may complain about this in another episode, there's not quite parity between seismic and wind loading. I wish there were. But these changes and these normalizations are nothing new. Dead loads, live loads, those are normalized to ASD and then amplified for LRFD. So we deal with it all the time. And we should be used to this as an engineering community. But what bothers me is clinging to the old or attempting to cling to the old. So before we get deep into that, Tim, why do you think we cling to the old way of doing wind loads? What is it that really sticks us there?
it's I think they just have the idea that the load combinations are going to be much simpler if things don't have to be factored. They think it's all just 1.0 wind, and they can just add things up. And it's a nice theory, but ASD really started diverging from that honestly a long time ago, and it's just gone more and more so to the point that we have load combinations that are every bit as complex with their factors in ASD as they are in LRFD. And in fact, if you go through and sum them up, there are actually more combinations required to complete a building design in ASD than there are in LRFD.
We're long past the 1.0 dead load plus 1.0 live load's all I have to know.
Right, and that's what they normally think, is that there's not going to be any factoring required, and it's therefore simpler. So if they just take care of it up front in the nominal case, then they've handled it all throughout, and there's less thinking to do. And it's a nice thought, but the fact is it doesn't play out like that.
Right. And then I think the other main factor that holds people to at least presenting the information in the old way of doing things is that your product evaluations haven't been updated, and they haven't been forced to be updated by municipalities or the authority, or the jurisdictions having authority, or the code. And we'll talk the reason why that is. But so then you get this disconnect between the way we design and the way we relay information to other interested parties. And that's can be confusing, it can be frustrating, it can also be dangerous.
Right, because the question comes up, what's the design pressure?
Yeah.
And people expect there to be one value to that.
Correct.
And when you use the term design pressure, well, it creates ambiguity. Are we talking, ASD or LRFD? So.
Right. Depends on your method. So to backtrack on some of the basic information, the relationship between the old wind speed and the new wind speed is simply the root of 0.6 multiplied by or divided into that number. So you can take the new wind speed and multiply it by the root of 0.6, and it'll get you back to the 2005-2000 ASCE7 wind speed. And that's where the code tells you if you're going to discriminate between the two wind speeds and use one for serviceability and one for design strength, whether it's ASD or LFD, you should be doing it at the wind speed and recalculating all those wind pressures based on the wind speed. What ends up happening, though, because there's a square factor on the wind speed, when you get to the design pressure size, the conversion between ultimate and allowable levels of pressure is 0.6. And so that's the shortcut that everybody likes to use. And I will admit, I use that all day long if I want to check deflection for something, because it's close enough to the process of going through the wind speed calcs. But I hesitate, and I don't, in general, show that speed to anybody else, or that pressure to anybody else that's derived through the wind calculations.
Well, and that's part of the problem, isn't it? That when we made that transition, we didn't make it completely. And by that, I mean, we really needed to update all the L-over criteria when we did that. Just like how seismic has ultimate levels of drift associated with their coefficients. It needed to be everything, not just partially.
I agree. And there's two things I can think of that the ICC really messed up, and I have stronger language that I usually like to use for it, with respect to this transition. The first thing that absolutely annoys me is the inconsistency between the residential code and the building code. So in 2012, the IBC says we're marching forward and using ultimate wind speeds as the normalization. But we're keeping the residential code at allowable level normalization. How confusing can that be? Right? You now have the document that contractors, architects, and homeowners, and a lot of product manufacturers rely on the residential market. They're trying to appeal to this large group of structures and professionals who design using the residential code. And here you come along as an engineer with your engineer design, and the wind speeds are 30, 40 miles an hour higher. If you're in Florida or along the Gulf Coast like I am, even larger disparity between the wind speeds.
It sounds like one of those classic lobbying things where, the residential side had more money lobbying on that side to keep it the way it was.
Yeah, it's like, can we not speak the same language? It would really go a long way, and it would push those product manufacturers to be compliant with showing us ultimate wind pressures for blow off, or your delegated designers not having to figure out what method you use. The second issue I have with the ICC is they misused the word normal and normalization and nominal in the new wind code, or the new wind language. They use V ultimate, VULT. That makes sense for an ultimate level wind speed. But rather than using, and then they use VASD for the allowable wind pressure for serviceability, but they call it the nominal wind speed.
Oh.
So, explain to me why that's wrong, Tim.
Well, number one, and honestly, more engineers need to get into this habit. You always load things at the nominal level and factor after that. So, if we're supposed to load the building at the VULT level, then that is the nominal speed by definition, or the nominal force, the pressures that you're putting on things. So that's it, really, in a nutshell.
And I always look at the nominal is the virgin, unchanged, the value that you spit out, whether it's seismic derivation, whether it's wind derivation, or it's adding up dead load values and tabulating that. That is a nominal load, and it may be normalized to one method or the other. I really like the NDS and the way that the wood code handles shear walls and diaphragms, because they give you a nominal table that is neither LFD or ASD, and they both have their factors to get to where they need to be based on their statistical analysis. And to me, that's the perfect example of what nominal should be, because there's no confusion, because you can't say it's one or the other, because they both have factors applied. And we need to get into that mentality of all nominal loads have factors applied, they just happen to be 1.0 sometimes. And that doesn't make them equivalent, it just means they have a factor of 1.0.
Right, that's not the definition of nominal, exactly.
And so here you have, in very clear, the code not sticking to a definition that is very well defined and very well understood. So now I get in conversations with people about wind speed and wind pressures, and I want to say the nominal wind pressure is based on 115 miles an hour in the center of the country, and they go, well, that's not nominal, that's ultimate. No, it's unfactored. And so that brings us around to the problem we face. Internally, however you do your calcs, it doesn't matter, I don't care. But when I go to send calculations or design criteria to a delegated engineer, to a fabricator, to an architect, to a product specifier, all of those things where I'm communicating what the loads are on my structure, I feel like there's 3 acceptable methods to do that. The first would be establish the design criteria, give them the wind speed, and say, you go do the ASCE7 calculations. I don't think that's good practice, but
no.
If you provide them the information, the odds are they're not going to get the same answer that you did, just because of tiny variations in rounding and all those things. So I don't think that's a good way of doing it, and at the very least, you're required to put that information already on the drawings.
Yeah, it's been for years now that's been required.
Yeah, so
I think it was 05.
Yes, anybody could recreate your calcs if they need to.
Mm-hmm.
The second method, and this is the method that I prefer to operate in most of the time, is that you're going to put virgin loads. You're going to put the nominal dead load, the nominal live, roof, snow, wind, and seismic, unfactored as they come out of ASCE7, which tells you what the loads are supposed to be. And so those will be in pressures, PLFs, bending moments, shears. Let the designer of the product or the extra pieces of components determine whether they want to use ASD or LRFD. I don't care, as long as they have a design. I would prefer they match what I use, but it's not required. And then I think the third option is you provide the worst case at a low level. So whether it's LRFD or ASD, you can state what V ultimate is, you can state what MA is, and then they have to design to that criteria. But you've taken all of the responsibility of determining what the worst case is. And on some structures, that's simple.
And all of this is parallel to the way concrete decided to do this way back when they went to an ultimate level approach.
Very clear.
And when steel unified under the 13th edition, they swapped their the concrete people actually swapped their load factors so that it started to unify, and they're all using the same statistical analysis. So yes, with intent, they're all moving toward each other, which means that the approach from a design standpoint should also be the same, regardless of which material you're working on. So we shouldn't be trying to invent some new hybridized version of old ASD under the new system.
Right.
We should just be following the same types of procedures for all these various materials.
And on the strength side of those equations, and not strength LRV, just strength both ASD and LRFD, we're looking at V nominal. That's very clear. V nominal is just the material strength on its own. And you're either applying a reduction factor, omega, for ASD, or another reduction factor for LRFD. That's what you're doing when you have those, Vn over omega. I don't understand how it got so confusing when we got to wind. It's like we all forgot what we were doing when this change came about, even though we do it everywhere else in the code. And so those three methods of presenting design information, design pressures, to me are the right way to do it. And option two being show the nominal loads, let the designer deal with it. I have compromised with folks in the past where I show both. I'm very clear that this is nominal unfactored load table, and then here's a table that's been normalized. I use that exact language to ASD, therefore they can match their product data to it. And the worst case scenario with that one is I get a question, well, which pressure do I use? And then we have a chance to communicate and talk about what's going on, why there's two values. I feel we've done a really bad job as engineers of pushing the specifiers to know what they're doing by giving them the correct information, and then when they go, this is coming out really expensive, or I can't find a shingle that's rated for that speed or pressure, then we educate them that things changed. Now it's a decade later, and we're still trying to educate them because we're not acting in unity. We're the impetus for change on this. They have no reason. Their inertia is going to keep them where they're at. We need to be the ones to produce this change. I think that's why I'm so passionate about it. Tim and I, when we were working together, we came across a set of delegated calcs that had taken the 0.6 factor twice. And you're like, that's just dangerous. If you specify the ultimate level normalization on your pressures and somebody selects the product based on that, it's more expensive, but it's safe. You're going to have a mistake in the correct direction as opposed to a detrimental direction, other than cost. So I think from a prudent standpoint, that's the side of the fence you want to be on. You don't ever want to be in a situation where a wind load has been reduced 40% twice. So any other thoughts on that, Tim?
No, I think that about covered it.
And I'm sure we can, I've had the arguments, and people are passionate about this both ways, and I understand not wanting to change. It just doesn't feel correct. That it's not the intent of the code, I guess, is the clearest way to put it. And don't ever tell me that there's a 0.6 reduction factor listed in the code somewhere, as I have seen on calculations. It's not there. It's a made-up reduction factor, and you're fooling yourself into thinking that it's codified.
I remember fighting that with the 1/3 overstrength factor for several years until people finally learned to drop that.
Yes. All right, that's the end of the code speech. So hopefully we can talk about a couple fun things and wrap this up relatively quickly. I had the opportunity, I don't know if it's an opportunity, I had the challenge of a secondary cylinder on my Chevy 1500 clutch going out. And yes, I still drive a manual transmission. I do enjoy manual transmissions. And Tim and I will talk about cars often enough, I think. And I've dropped transmissions on trucks before, and I've replaced the clutch, and I've replaced slave cylinders on S10s and things like that. So I don't like doing the work, but I'm not scared of it. And I had a friend helping me out, and we tore it down pretty quickly. And one night we got everything ripped off, and we're like, well, let's go ahead and swap out the clutch, and then we'll take off from that tomorrow. And it's a good thing we did, because we ended up hitting a wall that we had to go research. We got the clutch assembly off, and I was trying to pull out the pilot bearing so I could replace it. We could not get it to come out. It was jammed in there pretty good. So we licked our wounds, went home, and we both Googled it, and we kind of found some interesting methods for removing the pilot bearing. And I went and got a bearing puller tool that's designed for this. So I thought, oh, this will knock it right out. It's just 3 fingers that go in and expand behind the bearing. And so the next night we were working on it, and I go out there and I put in this bearing extractor and crank it down as hard as I can to get those fingers expanded, and start cranking on it, and the fingers started to flex and pop through the bearing. Did not move at all. Well, a couple of the videos that we watched, that we found, had people making plungers out of bolts, grinding them really, really tight to the bearing, and then they were shoving grease into the void behind the bearing, putting the bolt in and smacking it with a mallet to create a hydraulic cylinder, is effectively what it was doing. And sure enough, on the videos, they were knocking them out. It's a slow process. I thought, okay, I'll try it. I ended up with grease in my hair. Bearing hadn't moved. I mean, you got to get your plunger just perfect. So I found another guy, brilliant, said he uses bread instead of grease. Well, that makes sense. All that matters is that you get material to compress behind this bearing and build up pressure. I didn't have bread out in the shop, but I had blue paper towels, just shop towels. So I got a couple of them wet, and I started pounding them into the bearing. I felt so stupid. I felt like this is the stupidest thing I've ever done to fix a car or to work on a car. I'm pounding paper towels with a bolt and a mallet. And, they just kept compressing, and I started throwing dry ones in there. I feel like I didn't need that much water there, and they just kept compressing into these pellets. And eventually, one of the times I hit it, it lurched forward. I couldn't believe, and I started pounding in more. I mean, I understood the physics. Like, if I put material in, eventually it's got to start coming out. And it took 20 minutes, but eventually I smacked it, and that bearing shot free, and I had the most compressed paper I have ever seen. Just this hockey puck that I took another 5 minutes to dig out with a pick. I don't know. Cars should not be that difficult to remove parts. But it was, like I said, it was the stupidest thing. But it worked. It worked. So
Yeah, you think there'd be a little more consideration on the design end about the ability to get in and repair things in the future.
To pop out a bearing. I don't know. So that's my car story from the last couple months. I'm getting ready to do a motor swap, and I'm sure that will produce a ton of stories. But I wanted to talk about Tim's DeLorean. Yes, Tim has a DeLorean. But before we do that, Tim has a special talent, and that is he's very good with pronunciation.
Oh, man.
So I dub him the overlord of pronunciation. And there's a word, this is probably Tim's, he hates this word the most, I think.
I know which one you're going for.
Yeah, and it's Torsion. He hates the way I say it.
I asked everybody in my office once
so
to pronounce the word.
Clear the air on the correct pronunciation of torsion.
Right. Torsion. with an SH sound. I checked English language dictionaries in multiple countries, and not one of them has the ZH sound listed as an acceptable pronunciation. It's always just torsion, and that's it.
Beautiful. Now you just got to remember which way to go with that. And Tim's got a list, so we'll bring regularly to let you know.
I gotta dig that out.
Yes, what the overlord thinks about the way you pronounce things. So let's get into your DeLorean, Tim.
Yeah.
Give me the background on your DeLorean.
Oh,
it's
man.
fun. I've ridden in it. It's a cool car.
Yeah, I got it 2 years ago, and it spent its whole life living in Cincinnati, and uh, it only had 10,500 miles on it when I got it, and um, it was because it was owned by a father who sold it to his son, but then the father didn't drive it much to begin with because he had a bunch of other cars. The son ended up becoming, I believe what he said was IT security at the Obama White House. So he had to move to Washington, and he basically just left the car in Dad's garage. And 15 years later, they finally decided to part with it. So that's when I got it. And, it was in great condition. It just still, it's going on 40 years old. Things age out. So, you had to replace some basic stuff, hoses and belts and, water pumps and fuel pumps and,
How difficult
lines.
is it to get parts for a car that's that unique?
Yeah, that's what's interesting is that the company was geared up to produce many, many cars when they went under. So they were left with a warehouse full of parts when they went into receivership. And all of those parts, for the most part, are still together in one group, owned by what's now called the DeLorean Motor Company in Houston. And they sell the parts through a couple of distributorships in the United States that they own. They're basically, or that they're franchised. But there's one in Huntington Beach here near me. So, and we've got people there who've been working on DeLoreans forever. So, it's fantastic. Actually, you basically can't stump them. They've got the part. They know what to do every time. So,
well, it's a pretty tight community, right? So, I mean,
yeah.
with
Oh, yeah. That's another good point too. Is that we definitely, I know about 15 DeLoreans in the area and their owners. So you can definitely get a hold of the brain trust of people who've worked on this car, and the online community is the greatest. You put what you want to do online, and in come the suggestions telling you how to do it, and it's amazing.
You just refer to each other by serial number?
Yeah, kind of. That's what's funny. That DeLorean owners tend to know the VIN of their cars. So you can pretty much ask, what VIN do you have, and they'll just tell you. And the reason for that is because they were running design changes, and based upon where your car was in the run, you'll have this condition versus that condition, and that's really why it's like that.
What do people think when they see you driving a DeLorean in Long Beach?
So honestly, I had told people over the years that I wanted to get one, and they're like, "Oh, that's interesting, that's funny," things like that. But that would be about all I got, and I was expecting just about that level of interest from the world at large as I was driving it around. But I've discovered that actually having the thing versus talking about it is a completely different matter. And it's like driving around on Britney Spears. It's insane. The amount of attention that it gets is ridiculous and embarrassing. Honestly, it takes some getting used to. The first couple of weeks, I was constantly looking around to see who was looking, and after a while, I figured out it was basically everybody. And then once you realize that everybody's staring at you, you just kind of ignore it. I got the windows tinted and just go on with my life.
Getting noticed.
Yeah. The only good thing about it in terms of I'm not the celebrity, it is. So every time I park it and walk away, I get to be normal again. So
nobody knows who you are after that.
Yeah, exactly. Except at work, everybody knows I'm the guy with the DeLorean.
Yeah. So I imagine it garners a lot of attention, but having been with you in the vehicle, I know that when you drive around a mall parking lot with the Goldwyn doors open, that tends to attract attention to yourself.
Yeah, it's funny. You can drive in the parking lot with the doors open. There's a practical purpose for it too. If your car is hot, guess what? Not for very long if you drive with the doors open. So
it's not down the freeway.
And usually, I wouldn't do that. Although it's been done, but I would not. But it looks great being made of stainless steel. He was right. The finish looks fantastic still, and the engine's practically bulletproof. I know of a guy who has over 500,000 miles on his, and more than one person who has more than 200,000 on it, and they just keep going. That guy I told you who repairs them, he said when he opens up the engines, to go inside to do whatever needs to be done, he said he's always amazed at how clean it is. He said it's the cleanest engine inside he's ever seen. So it was used in rally racing and road racing and turbocharged up to high heaven, and it's a really strong engine, so it does great.
Is there a time machine at all in your future?
No, definitely not. Although a lot of the people who are into DeLoreans do it because they're into Back to the Future. I actually liked the car before that, and I like the movie just fine. But I mean, like, no more so than any other movie. And I'm certainly not going to, go out and buy an expensive prop for any other movie either. But that's part of the fun of it. For a lot of the people who do it, they put fake flux capacitors in them and stuff like that. And, it's funny. Not my thing, but they like it.
What really surprised me, my dad had an RX-7 when I was a kid, and that thing sat low to the ground. But I think you could drive the DeLorean underneath the RX-7. You felt like you're scooting along across the pavement.
Yeah, I drove under a parking gate once when I couldn't get the ticket to take. But when you're standing next to it, it's the roof is the height of my belly button. Really, really low. I think it's 4 or 5 inches lower than a Corvette. So, yeah, it's crazy how low it is.
Yeah, you sit on the ground. It's an interesting experience on the freeway.
Yeah.
To be that low and not be on a track.
Yeah, for every Civic you drive by to look like an SUV. It takes some getting used to.
Is there anything you would tell somebody looking to get a DeLorean? I mean, what's the key?
I guess the key is to sort of do your homework, I guess, which is what anybody would say in the classic car world. But it's pretty easy to jump onto the boards and just start reading and get a sense for what you're getting yourself into and what's good and what's bad and what the typical problems are and how to get around them and stuff. Because if you know what you're doing, it's a pretty easy experience, really. And if you don't, you can make life pretty hard for yourself. Which I think that's good classic car advice in general. And yeah, it's like I said, coming on 40 years old, so it's classic car ownership.
That's awesome. It looks great. I mean,
thanks.
Everybody knows what it is. That's the beautiful nature of that car, is that it ran. Yeah. They're just enough made, and the movie made it iconic. Everybody knows the DeLorean.
Kids, adults, doesn't matter. Yeah, everybody knows.
Well, that's awesome. Well, I think that's all. We probably overstayed our time and welcome. So if you've made it this far, thank you. But Tim's DeLorean's awesome to talk about, and he will talk about it all day long if you want to.
Shut myself up.
Yeah. So again, thank you for joining the Rankled Engineer. I'm Gates. This is Tim, and we hope to be coming to you again. Have a good evening, morning, or night, whatever it is. Thank you.